Hey y'all, it's your math teacher, Mr. Boyden, back at it again. Today we're going to talk about definitions in math and a few different important angle relationships. Still going to be a lot of vocab today, although we'll get to do a little bit of thinking and really do some critical thinking with the definitions. So let's jump right in, okay? First one, I have a definition here and we're going to test it to see if it's a good definition. And here it is. The definition is, an airplane is a thing that flies. And then my claim is that that's not really a complete definition. And one way that we can find out if it's a good definition is if we can find a counterexample. A counterexample is just an example that proves that this is not always true. So an airplane is a thing that flies, and we're going to say, can I think of anything that would not fit this definition? An airplane is a thing that flies. How about a bird is a thing? Because birds also fly. So to just say, oh, airplanes are things that fly. I mean, I guess it's true. Do all airplanes fly? I mean, I guess ones that don't work very well don't fly, but it's not a very complete explanation. Or like a paper airplane. Is a paper airplane really an airplane? I don't know. Okay, so we can find lots of different counterexamples of things. Or how about mosquito? A mosquito is a counterexample because a mosquito is also a thing that flies. Okay, let's see some more examples. Let's do one that's actually in math now. So here's a claim that everyone knows a square is a figure with 4 equal sides. And so let's see if we can find a problem with this definition. Let's see if we can sketch a counterexample. So what I would like you to imagine that you were in a room and someone actually made this statement. Well, a square is just a shape that has 4 equal sides. That's what it is. And if you wanted to argue with them, if you wanted to be kind of difficult, how would you do that? What would you show them to say, actually, that's not quite right? So maybe pause the video and try to draw one. Here's my example. What if I draw like this? 4 equal sides, and yet that's pretty clearly not a square. And it's my best attempt to draw 4 equal sides, right? So that's actually a rhombus, or some people call it a diamond. So that's something that has 4 equal sides, but it's not a square. Now, I mean, it's true that a square does have 4 congruent sides, but it takes a lot more than that. So what was missing in that definition that allowed me to write a rhombus instead of drawing a square? Let's write a better definition. Well, you probably already know that a square needs to have 4 right angles and 4 congruent sides. Yeah, and let's get in the habit of saying congruent, not equal. Okay, so if it had said a square is a figure with 4 right angles and 4 congruent sides, we'd say, well, yeah, that is a square, absolutely. Okay, so that's a little bit more specific. Now, in the real world, we can be a little sloppy with our definitions. People go, well, you know what I mean, you know what I mean. In math, there's no such thing as you know what I mean. Like, you gotta really label it out and write everything out, okay? All right. So now for a few new symbols that you may or may not have known. I'll highlight them to make sure they stand out. Okay, the first one is the parallel symbol. And that's right there. And it basically looks like an equal sign that got turned and is going up and down now. And so down here we can see how it's used. This says that line I is parallel to line J. And the other thing that I want you to notice is you see these symbols on here? Those symbols tell us that those two lines are parallel. Now, I want you to notice the difference, okay? Because earlier we had talked about putting on symbols like this. I want you to notice this is not the same, because you see how these ones are kind of like arrows? So if they're little arrows, it's saying that lines are going in the same direction, so they're parallel. If they're little tick marks like this, and they look like they're equal signs kind of, then that means that they are congruent. All right. The next symbol and the next vocab is over here. Okay, and that is like an upside down T, and it stands in for perpendicular. Rather than having to write the word perpendicular every time, or is perpendicular to every time, we just put that upside down T. And you may have already figured this out from the picture, because look at these labels in here. Perpendicular means that they are making a right angle, or a 90-degree angle. Okay, so that's what this is saying. It's saying, and you have it right here, it's saying that the lines K and L are perpendicular to each other. Another way of saying that is at the point where they intersect, they make 90-degree angles. All right, here's a quick vocab check. I think we talked about this in the previous lesson, but it's a good reminder. So what vocab word applies to all three of these pictures? There's actually a couple. You could have right angle, and I'm using the symbols now to save the words, or you could say perpendicular. There's that symbol again. There are perpendicular lines in these pictures. Here's another one. What word applies to all three of these angles? Each of them is less than 90 degrees. These are all acute angles. And what about the last one? What vocab word applies to all three of these angles? Well, all of them have more than 90 degrees. These are obtuse angles. Now, there is one other kind of angle that we had not talked about yet. Okay, so we already know that, like, if you had a line coming down like this, you could have a right angle. But what if that opened up and sort of laid down flat like this? What would that be? Well, you could probably figure out that since there's a 90-degree angle on either side, this whole angle is a grand total of 180 degrees. Now, another way of thinking about that is, notice this right here, this arc, that's half of a circle. And if you go all the way around a circle, that's 360 degrees. So half as much, half as many degrees, that's 180 degrees. I do want to add a piece of vocab here, and you need to include this in your notes, please. This is called a straight angle. And it just means that, like, yeah, there's a point here that has a ray going left and a ray going right, and it's making a 180 degree angle. Okay, so a straight angle is always 180 degrees, just like how a right angle is always 90 degrees, straight angle is always 180, because two right angles next to each other. All right, now, there is a vocab word for a situation that's like this, but when we put a line down the middle of it. So I'm going to draw that out. You probably want to draw that out as well. So imagine that I have some straight angle and there's a ray coming out of that point in the middle, like this. Now I have not drawn this so the two angles are equal, and that's totally fine. Okay, so I'm going to call this angle 2 and I'll call that angle 1. These two angles, they share a line, right? Like when you put the two of them next to each other, they fulfill that line, like angle, angle, they make a straight angle. That's called a linear pair. And a linear pair always adds to 180 degrees. And that's going to be important a little bit later in the class. And you know what? The next word is similar, because instead of always writing out adds up to 180, adds up to 180, we have a word for that. And that word is supplementary. Supplementary angle is describing any two angles which add to 180. You go, well, Mr. Boyd, why do you need both words? Why do you need linear pair and supplementary? The reason is because not all supplementary angles are linear pairs. Let me give you an example. Let's say I had a 90-degree angle here, and I drew a totally separate 90-degree angle over here. These two angles, because they're both 90, they do add up to 180. So this pair of angles is supplementary. But since they're not oriented right next to each other and making a complete straight line, this is not a linear pair. So that's why we have two different words. Supplementary just means they add up to 180, okay? And we have an example here. Maybe I'll label it with some numbers. Maybe this is 60 degrees, and maybe this side over here is 120. So this is both a linear pair and supplementary. It is both. All right. Another piece of vocab, we have another one called complementary. I bet you could make an educated guess based on the picture. We have two angles here, A and B, and these two angles, what would they add up to? Complementary means that it's two angles which add up to 90 degrees. Now, when I was taking geometry, I would always confuse supplementary and complementary. So let me give you just a really quick way to remember, okay? So complementary is 90, supplementary is 180. And actually, a student my first year teaching showed this to me, and I'm like, what? Where have you been all my life? I needed to know this. So complementary comes first in the alphabet, like C comes before S. 90 is a smaller number than 180, so the one that comes earlier is smaller, the one that comes later is bigger. That's just, and ever since a student told me that, I was like, oh, well, of course I can remember that now, and I have not forgotten it ever since. So thanks, student. All right, there's also something called vertical angles. Vertical angles are not real hard, but they can be confusing at first. Why don't you draw the picture if you haven't had a chance to already? And in this case, angles 1 and 2 are vertical. Now that might sound a little weird because they are across from each other left and right. You go, wait, hold up, man. Don't you think they're horizontal instead? No. So vertical angles, in this case, it is not referring to up and down. So they could be. Like, for example, if I call this angle 3 and angle 4, angles 3 and 4 are another pair of vertical angles. So, and what you could think about is, like, if I folded this image across that line, angle 3 would land perfectly on angle 4. The other thing I want you to notice and think about is, how do the sizes, the numbers of degrees in these angles compare to one another? Like angle 1 and angle 2, which one has more degrees? I hope you can see that one is not larger than the other. So I'm going to make a note here. Vertical angles are always congruent. They have the same number of degrees. And that's going to be important later in the course. So we're just kind of getting our base knowledge. Now guys, to identify vertical angles, look for an X. Okay, and this is just Mr. Boyden's way of kind of thinking about it. And what it is, anytime you have two lines or segments that are crossing, there will for a fact be vertical angles produced, okay? As long as they're not curvy, as long as they're straight lines. So if I go like this, there are vertical angles, and let me label them, okay? So this angle is vertical to this one, and they are congruent. This angle is vertical to that one, and they are congruent. Same thing over here, okay? Congruent angles here. And then the ones that are across from each other here are also congruent, but they're different from 1 and 2. So that's the giveaway. Two lines crossing, for a fact, there's vertical angles in there, okay? And they are going to be congruent always. That's going to be all for our introduction to some new angle pairs and just some quick thinking about counter examples and some definitions. I hope you enjoyed the video, and I'll see you next time.